Hello, geometry students. It is Calleva week, day 3. We have made it this far. Let's keep going. I'm making all these videos at the same time. I've been talking into my phone for like 2 hours now. I'm getting pretty loopy, so this should be fun. You should be watching this video on Thursday in class if you're in periods 4 or 8. Or on Friday if you're in period 5. Okay, so class today started with a quick quiz. You should already be done with that. If you're not, if you haven't done it yet, say, "Teacher, we need to do the quiz first." Okay, she's got a printout for you. Do it. You're gonna enjoy it, I think. Okay, so let's go over your homework then. I'm going to try to do it faster than last time, because last time I spent like a half an hour just going over homework. Although this time it was just textbook homework, so it should be a little quicker. All right, so I assigned chapter 3, section 1, numbers 6 through 9 all. So let's go back, chapter 3, section 1, back. Oh, look at that. That's some nice boats. Okay, here we go. Problem 6 through 9. Just name the pair of corresponding angles. So all the pairs. 1, 2, 3, 4, 5, 6, 7, 8. You can see these numbers are not the same as the numbers I gave you because we don't have standard numbers. We just remember the relationships. So corresponding angles, those are the angles that are in the same place. So 1 and 5 are in the same place, 2 and 6 are in the same place, 3 and 7, same place, 4 and 8, same place. Name a pair of alternate interior angles, 4 and 6, how about, or 3 and 5. Alternate exterior angles, that's 7 and 1, or 2 and 8. A pair of consecutive interior angles, that's angles on the same side that are in the interior. I'm going like this right past 4 and 5, so yeah, 4 and 5. 3 and 6, also consecutive interior angles. So there's 6 through 9. Let's look at 21 through 26. My book and my stand just don't really work well together. So it's going to be a little crooked, maybe not. Yeah, we'll just have to do that. All right, so here we are, there we are. All right, number 21, 8 and 12, those are corresponding angles. They're in the same place, right? 8 and 12, they're both to the bottom left. 9 and 14, one's on the top, one's on the bottom, so they're alternate and they're exterior, so alternate exterior. 10 and 12, alternate, not alternate, sorry, consecutive interior, right? 24, 11 and 12, where are those? Those are on alternate sides of the transversing line and in the interior of the two lines being transversed. So sounds like alternate interior to me. 8 and 15, those are on the alternate sides and they're on the exterior, so alternate exterior. 26, 10 and 14, those are in the same place. Both of them are in the bottom right, so corresponding. All right, so those were the easy parts, right? Just identifying stuff. So let's look at the next part. That was chapter 3, section 3, 11 through 26. So I think this is where it got a little more interesting. 11 through 26. Yeah, let's do some algebra. All right, so easy stuff. What are we doing? We're finding the values of x and y. Let's explain our reasoning also. Where's this 67 belong? It looks like it belongs right here. So what do we get for x? Looks like we get 180 minus 67, which is 113. And this, well, those are alternate exterior angles. And what do we know about alternate exterior angles? Well, we know they're congruent. So if alternate exterior angles are congruent, then I guess y is also 113. we should be really careful not to just jump to conclusions about the relationships. We need to make sure that they're parallel lines. We see that we have parallel line markings in all of these diagrams, so we don't really have to worry about that. Well, we do have to worry about it, but we're satisfied. All right, so in number 12, y is equal to 109. Why is y equal to 109? Because vertical angles, that's why. How about x from number 12? Looks like x and 109 are consecutive interior angles. I know that consecutive interior angles are supplementary. So 91, 80, 71, gosh. 71, x is 71, because 71 plus 9 is 80. So 71 plus 109, 180. Number 13, x is equal to 90, y is equal to 90. Why? Because they're transversals by a perpendicular, right? Being transversed by a perpendicular line. So all 8 angles are 90 degrees. Number 14, x is 65, y is 115. Okay, I'm going to try to start moving a little faster. Number 15, x is 100, y is 80. Number 16, x is 130, y is 130. Let's look at number 17. Number 17 says, oh, I just cannot get to the top of the book to work with me here. Sorry, this is really horrible videography, like at its worst. If you haven't guessed, I'm just recording this with my cell phone. So technology, super awesome. There we go. 17, using properties of parallel lines. Use the given information to find the measures of the other 7 angles. The other 7, what do you mean other 7? Oh, 107 is given, the other 7 are not. So this is kind of like your checkpoint activity yesterday. Well, I know 4 is 107. 8 is corresponding to 4, and these are parallel, so 8 is 107. 5 is 107 because vertical angles. And then there's just the supplements left. So 73 for 2, and then 3 is vertical to 2, so that's 73. 7 is corresponding to 3, so that's 73. 6 is corresponding, or excuse me, is vertical to 7, so that's 73. Awesome. 18, let's see, 18 through 26. 21, or excuse me, 18. Correct answer is 35. Those are alternate interior angles. You should set them equal to each other. 19, 23, those are alternate exterior angles. Those are also congruent. Set them equal. 20, the answer is 10. 6y and 120, what's the relationship between these? Well, they're consecutive interiors. So since the lines are parallel, those are supplementary. So we should have 6y plus 120 equals what? 180. That should look familiar. Where'd I get it from? Looks like, I think you saw that in your quiz. Your quick quiz. Number 21, looks like the answer is 28. How do I know that? Well, 70 and 3x minus 14, those are corresponding angles. I think that one also looks familiar to you from your quiz. 22, so I guess looks like I hope you did your homework last night. Your quiz should have been pretty easy then. 22, there's a right angle, and these are parallel. So all 8 angles are 90 degrees. So it looks like 2x plus 10 is 90. Gives us x equals 40. What about this transversal? It's with parallel lines. These are alternate exterior angles, so they are equal. So let's set them, the measures are equal. I should say the angles are congruent. Let's set these measures equal. We get x equals 12. 24, 89 is the same. Is it the same? These are same side. These are same side exterior. We didn't really have a name for same side exterior, so let's think about it. What do we know about 89? We know that it's supplementary to the angle that is congruent to this, because it's supplementary to this angle here, which is corresponding to this angle. So this angle and this angle are the same, which means by the congruent supplements theorem, actually I suppose it's the converse of the congruent supplements theorem, this angle is supplementary to 89. So if you didn't discover last night in your homework, the relationship between same side exterior angles is that they're supplementary. So 5x minus 24 plus 89 equals 180, x equals 23. 25, this angle is supplementary to this angle, which is corresponding to this angle. So again, this relationship is a supplementary one. So 13x minus 5 plus 94 equals 180. Do a little algebra, and I get x equals 7. Do a little algebra. I'm really into turtles right now, you guys know that. And my turtle tank's growing a little bit of algae, which is good because it feeds little fish. And I'm going to talk about algebra a lot more now. Number 25. Let's see. What is the relationship between these angles? Those are corresponding. So we should have 7 times x minus 7. That's 126, or I should say equal to 126. I want to see all those reasons why. Remember, we need to justify things. We're in geometry. Okay, we don't just write statements, we justify statements. So I need to see things like 7 times x minus 7 equals 126 because corresponding angles. Okay, that's fine. I don't want to just see an answer. I want to see an equation. I want to see why you wrote the equation, and I want to see what you got when you solved the equation, and I want to see how you solved it. So there's all through 26. Then let's look at number 29. It was to prove the perpendicular transversal theorem. Prove the perpendicular transversal theorem. I asked you to do it using analytic geometry. There it is, 29. You can barely see it. I'm gonna do that one for you as a start. I flew through that homework assignment. That was really good. As always, if you have any questions about homework, come see me during pause, except for this week, because I am currently, let's see, what is it? It's Friday. What am I doing on Friday? I'm hiking. I'm hiking right now on the Appalachian Trail with the whole freshman class. I don't know. What time is it? Oh, it could be Thursday too. So I could be trouncing through a cave right now, checking out some stalactites. That's one of my favorite words. I'm going to be saying it all week. These freshmen, they're going to hate me so much. And my stalactites. All right. Anyhow. So let's get started with this example. I closed my book. So I wanted you to prove the perpendicular theorem. So for parallel lines, we want to use analytic geometry to demonstrate that if the angle here is 90 degrees, then the angle here is 90 degrees. Now I'm going to only mark one of them because only one of those things is given. And I don't want to mess myself up saying that I can depend on this angle being 90 when really that's what I'm trying to demonstrate. So we're going to do actually kind of the same process for a proof, but we're not going to write a 2-column proof. We're just going to try to show the result, or to obtain the result using our symbolic geometry, our analytic geometry. So what do I know here? I know a couple things. I know that these two lines are parallel, right? Because I want to prove the statement if two parallel lines, well, let's say, that's not really a good way to say it. Let's say if two lines are parallel, and one is perpendicular to a third line, Okay, so that's this situation. We've got two lines that are parallel. This one's perpendicular to a third line. Then the third line is also perpendicular to the parallel. This light is driving me crazy. Stalactites. Okay, so let's do this. What I'm going to do is I'm just going to do the same thing I did a couple days ago, if you remember, when we were talking about parallel lines. I just gave them the same slope and a different y-intercept, right? So let's say this one has an equation y equals mx plus b1. This one has an equation y equals mx plus b2. Okay, so these lines are not the same line as long as b1 and b2 are not equal to each other. And they're parallel as long as this m is equal to each other. But by the reflexive property of equality, every number is equal to itself. So these slopes are the same. Now I have a perpendicular line. So let's see. So I'm just gonna say, since should I name these lines? I'm gonna name them. Let's name them S, T, and L. Okay. So since L is perpendicular to S, the slope of L is -1 over m. Right? The slope of L is -1 over m. Well, how do I know the slope of L is -1 over m? Well, the slope of S is m. And so then if L is perpendicular, then the slope of L is the opposite reciprocal of the slope of S, which is m. Okay? What do I want to demonstrate? I want to demonstrate that the third line is also perpendicular to this line. So really what I need to obtain, what I'm seeking, so what do we seek? We seek the fact that the slope of t is the opposite reciprocal of the slope of L. Well, now I have an expression for the slope of L. So let's see what the opposite reciprocal of the slope of L is. Well, that's pretty easy. The opposite reciprocal of the slope of L is -1 over the slope of L. But -1 over the slope of L is the opposite of, I don't know if this is going to be, this might be a little cumbersome. Okay, so let's do that though. The opposite reciprocal of the slope of line L, that's -1 over the slope of line L. The slope of line L is -1 over m. So this is -1 over m. That is just super ugly because it's a compound fraction. We don't like those. How do we clear a compound fraction from algebra? If you remember, we multiply the numerator and the denominator by the denominator of the compound fraction. Okay, so these cancel out. I'm left with an m on top. So I've got a negative m over, what does this turn into? -1. What's negative m over -1? Well, m over -1 is negative m. M over -1 is negative m. The opposite of negative m is just m. But m is the slope of t, right? So we just got that applying the opposite reciprocal rule for the slope of L, we get the slope of t. which means L and T are also perpendicular, which is what I wanted to show, right? So I'm going to conclude, so MT is equal to negative 1 over ML, and T is perpendicular to L. There we go, some synthetic geometry. There might be a little bit of a more straightforward way. You know, knowing that line T has the equation y equals mx plus b, this is probably the better way to do it. That's why I said the other way was cumbersome. What's the slope perpendicular to this line? It is, so a perpendicular line implies that the slope is negative 1 over m. Well, that's what we're going to have for L. So L is perpendicular to T. This is less writing, so probably better. Okay. All right, so what do we want to do today? Today we've got a little bit more time. I'd like to talk about those postulates and theorems that I gave you. So I want to remind you of what they were. The postulate 15, said that two parallel lines, or excuse me, that said that if two lines in a transversal are parallel, then corresponding angles are congruent. And I had some green and red marks. Bam. So that's what postulate 15 says. It says that parallel lines implies corresponding angles are congruent. That's pretty useful. That was the postulate. It's called postulate 15 in your book. Let's just remember it as perpendicular lines imply corresponding angles congruent. Okay? The angles aren't necessarily congruent if the lines are not parallel. And then there was 4 theorems. 1, 2, 3, 4. What was it? It was that if the lines are parallel, all of these are if the lines are parallel. The first one is that alternate interior angles are congruent. So alt int angles congruent. This is all review from last class. The next one was consecutive interior angles congruent. The next one is that alternate exterior. Ooh, I did that. I always just want to say everybody does. I'm not going to be hard on myself here. I caught the error, so that's what counts, right? Consecutive interior angles are not congruent. They're not. Here they are. What are they? They're supplementary. Okay, sorry about that. Alternate exterior angles. I was testing you. You passed. Good job. Those are congruent. Alternate exterior. And then the last one, there wasn't a thing about same side exterior, so don't write that for the next one. It seems like it might flow nicely, but that's not it. It is, however, that in a transversal of parallel lines, if one line, well, let's just say perpendicular to, there we go, now I have names. Perpendicular to L implies perpendicular to S. So if a line is perpendicular to the first one, then it's perpendicular to the second. I didn't really have to redraw that, but this one doesn't really look perpendicular. Oh my gosh. Mr. George is making fun of me because I'm still here at this late hour. Okay, so these are not, I mean, these are definitely true statements, but we can go a lot further with these. These implications here are actually, these statements are true. And I wanted to teach you just these statements. Just the if and only if statements. originally and then talk about the implications both ways, but it just didn't really work out like that. So what do these statements really say? It really says that two lines, let's look at just the postulate. Two lines in a transversal, let's say the two lines, meaning the two lines here and not the transversing line. The two lines in a transversal are parallel if and only if, oh, come on, that light. If and only if corresponding angles are congruent. If and only if corresponding angles are congruent. Well, you say, Mr. Hedman, what difference does that make? How is that really different than what we already have? Well, it implies a second statement. Remember, a biconditional is called a biconditional because it implies two conditional statements. Okay, the first one is that parallel lines imply that the corresponding angles are congruent. But also the other way is true. The other way. So here's the hypothesis, here's the conclusion of this particular statement that's given to you as postulate 15. Well, the converse of that statement is also true. That corresponding angles being congruent, that's a bad congruent sign, there we go. That implies that my lines are parallel. Okay, so if I see a situation in which corresponding angles are congruent and I don't know that the lines are parallel, I can conclude that the lines are parallel. So let's look at an application that you'll see in a lot of your homework problems as I find your homework problems. Almost. Sorry, guys. Just blank white space. This is fun. How have you guys been doing this week without me? Have the subs been good? I bet they're really nice. I know who they are, but I don't want to say their names in this video because they haven't given me permission to do so. All right, so here's an example. Here's the type of example that we'll see a lot. All right, so we get a parallel, we get lines, excuse me. We get lines and we get a transversing line. Now, these lines are not marked parallel, so we cannot assume they're parallel. Just like the very first transversal we talked about when, remember those lines were all wonky? Okay, all week we've been talking about transversals with parallel lines. Students tend to forget, just because it's a transversal doesn't mean these lines are parallel. We get used to working with transversals with parallel lines because they're more interesting. But this is still a transversal. So the question is, when is this this? Well, transversal is parallel, according to the postulate, whenever corresponding angles are congruent. So let's look at something like this. So suppose we have an x here and something like 15 here. This is a really boring example. They'll say, find x so that line L is parallel to line T. And let's say this is L and this is T. So what they want you to do is kind of like force a condition onto x so that these corresponding angles are congruent. Okay, so notice that I'm just going to say x equals 15. Okay. Why do I conclude that? Well, if x is equal to 15, then this angle is congruent to this angle. And since they're corresponding angles by postulate 16, then now these lines are parallel. So if x is 15,